Hello, welcome in the 13th Faculty Induction Program organized by UGC Malviya Mission Teacher Training Center and HRDC Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar. I am Dr. Pranita Joshi, Assistant Professor in Chemistry at Saraswati Bhuvan Science College, Chhatrapati Sambhajinagar. My seminar topic is aldol condensation. Now, aldol condensation is a very important reaction in organic synthesis because it is useful in the formation of carbon-carbon bond. So, what is aldol condensation? Aldol condensation is a reaction in between two molecules of aldehyde or two molecules of ketone in the presence of a base to form beta hydroxyaldehyde or beta hydroxyketone. The reaction is known as aldol condensation reaction. Now, this reaction, it can be continued followed by dehydration reaction to give a conjugated enone. Now, the important point regarding the aldol condensation is that the starting material, either an aldehyde or a ketone, which is taking part in the reaction, it should have at least one alpha hydrogen atom. This is the necessary condition. If the aldehyde or ketone is not having alpha hydrogen, then the starting material is not undergoing aldol condensation reaction. And the various type of bases which is mentioned in the definition, the various type of bases which are generally useful in the aldol condensation, they are sodium hydroxide, potassium hydroxide, sometimes tertiary potassium tertiary butoxide or sodium ethoxide. It may be used as a base in the aldol condensation reaction. Now this aldol condensation reaction, it is either catalyzed by acid or it is catalyzed by a base also. But here we are going to discuss the aldol condensation in presence of base. Now the very typical and very famous example of aldol condensation is the reaction of aldehyde, because this is the starting aldehyde. This is the first member followed by formaldehyde. This is acetaldehyde. It may be also known as ethanol. Here we have carried out the reaction between the two same molecules of acetaldehyde. Therefore, it is taken as two equivalent. Two molecules of acetaldehyde in presence of sodium hydroxide undergoes the aldol condensation reaction and it will result in the formation of 3-hydroxybutanol. Now see here why it is known as a beta hydroxyaldehyde or beta hydroxyketone, the product. See here, the main functional group in these reaction or in the product is the carbonyl group. This is carbonyl group, this is aldehyde. Now adjacent to this carbonyl group, this carbon is the alpha carbon, and adjacent to the alpha carbon, that is the second carbon, which is a beta carbon. See here, carbonyl group, one carbon and then followed by another carbon. So this is the beta carbon which is having a hydroxyl group. So the carbonyl group of either aldehyde or ketone and the hydroxyl group is present at two carbon atom apart from that, that is at beta position. Therefore, the product of aldol condensation reaction is beta hydroxyaldehyde or beta hydroxyketone. Now, in this particular example, when two molecules of acetaldehyde in presence of sodium hydroxide, they are undergoing aldol condensation, we are getting 3-hydroxybutanol. Butanol means it indicates an aldehyde. This is beta hydroxyaldehyde. This is the aldol product. Now, I have already told that the reaction, it may be carried out in the presence of either acid or base. So, this is the general representation of aldol reaction. See here, this is R, C double bond O. This is the carbon which is bearing alpha hydrogen. Alpha means the carbon which is adjacent to the carbonyl group. Now, why here alpha hydrogen is important? All of you know that the carbonyl group is an electron withdrawing group, and therefore the carbon which is adjacent to the carbonyl group, and the hydrogen which are present on that carbon, they become highly acidic in nature, and therefore they can be easily abstracted by the base. So this alpha hydrogen, it plays a very important role in aldol condensation. Now, if here this R, it represents a hydrogen, it is an aldehyde, or if instead of hydrogen, there is another group, it is a ketone. So this is one of the starting material, RCOCH2R, which is bearing alpha hydrogen atom. And now this is another carbonyl compound. That is a simple ketone. Now this H plus or OH minus means that this reaction, either it may carried out in presence of acid, that is H plus, it indicates acid, and OH minus, it indicates the base. So either in presence of acid or base, the aldehyde, this particular example, it indicates the reaction between two ketones. So it undergoes aldol condensation reaction. It is giving beta hydroxyaldehyde, and then later on it may undergo dehydration. So in this particular example, hydroxyl group from this beta carbon and one hydrogen on this alpha hydrogen, it may be eliminated in the form of water molecule, and hence we are getting a double bond in between these two carbon atom, alpha and beta carbon atom. So it may leads to unsaturated compound with loss of total molecule. So this indicates the complete aldol condensation reaction. Now we see some important features of aldol condensation reaction. Here we are going to discuss about the aldol condensation in presence of base. Okay. Now this reaction, it is a reversible reaction. It means that the aldehyde which are taking part in the reaction, it may be converted into the aldol, and as it is a reversible reaction, they may be again converted into a aldehyde or ketone which are taking part in the reaction. Now, generally, in this aldol condensation reaction, hydroxyl ion OH minus, it is a base typically used in the particular reaction. For example, here I have mentioned sodium hydroxide and potassium hydroxide. But instead of that, potassium tertiary butoxide or sometimes potassium carbonate, it may be used as a base in aldol condensation reaction. Now, this aldol condensation reaction, it is not particular that the reaction may be carried out between two aldehyde, or the reaction may be carried out between two ketones, or sometimes the reaction, it may be carried out by using one aldehyde or ketone. Therefore, the aldol reaction, it may be carried out either by using aldehyde or ketone, but the necessary condition is that one of the reactant, it should have alpha hydrogen, which is necessary for the generation of enolate ion or a carbanion. Now, when we are carrying out the reaction with aldehyde, two aldehydes, the equilibrium of the reaction, it favors the product, while when the same reaction it carried out with two different ketones, the equilibrium favors the starting material. That is, the reaction favors to the ketone. See. Now, we study about the mechanism of aldol condensation, that is the mechanical part of this reaction. Now, this reaction, it is completed in three steps. It follows three steps. So, in the next slide, we will see the mechanical, that is the structural part of this reaction. But the first step of this reaction, here in this reaction, the hydroxide ion, it is acting as an base. Now, what is the main function of base? The function of base is to remove hydrogen, or we can say that proton. The main function of hydroxyl ion is to remove a proton. Now, already I have told you that the alpha carbon atom adjacent to the carbonyl group, because of electron withdrawing nature of carbonyl group, it becomes highly acidic in nature, and therefore it can be easily abstracted by a base. Therefore, the first step of this reaction is that the OH minus ion, it is acting as a base, and it removes a alpha hydrogen atom, giving the reactive enolate ion. So this reaction is a acid base reaction. Now see here, I will show you here. See here, this is the first step of this reaction. This is OH minus ion, which is acting as a base, and now this is carbonyl group. This is the alpha carbon. So this OH minus ion, which is acting as a base, it is taking a proton from this alpha carbon, which is alpha hydrogen. Because of that, these electrons, they are transferred in between carbonyl carbon and this alpha carbon. And as this carbonyl group is an electron withdrawing group, the electrons between carbon and oxygen, they move towards the oxygen. Therefore, this is the first step of this reaction. Here we are getting an carbanion, and as these electrons are in the carbon, they are transferred in between carbonyl carbon and alpha carbon. We are getting here a double bond in between carbonyl carbon and this adjacent carbon. So this moiety, it is known as a enolate ion. This is the first step of this reaction. Hydroxide ion functions as a base and removes alpha hydrogen atom, giving the reactive enolate ion. This is the first step of aldol condensation reaction. Now the second step of aldol condensation is that this carbanion, which is acting, this carbanion or the enolate ion, which is having a negative charge, it is acting as a nucleophile, and then it is going to attack on the aldehyde carbon. Now, why this aldehyde carbon, it is acting as an electrophilic carbon. Why it is acting as electrophilic carbon? Because we know that carbonyl group is an electron withdrawing group, and there is a considerable electronegativity difference between carbon and oxygen. Therefore, generally, the electrons, they move towards oxygen. As the electrons, they are moving toward the oxygen bears a negative charge and carbon, it bears a positive charge. Therefore, in aldehyde, the carbonyl carbon, it is acting as an electrophilic carbon. So, the enolate ion which is generated in the first step, it is going to attack on the electrophilic carbon. Now here, as the enolate ion, it is acting as a nucleophile and it is going to attack on the electrophilic carbon. This step, it is a nucleophilic addition reaction, and this results in the formation of an alkoxide ion. This is the second step of this reaction. And in the third step of the reaction, the alkoxide ion deprotonates a water molecule. Actually, the third step of the aldol condensation reaction is the hydrolysis. Hydrolysis means we are going to add a water molecule. And all of you know that water dissociate into H plus and OH minus. Okay. Now the alkoxide ion, it is having a O minus, so it takes proton from the water molecule, and it means that the alkoxide deprotonates a water molecule, creating a hydroxide ion and beta hydroxyaldehyde or aldol product, giving results in the formation of beta hydroxyaldehyde. So again, this is an acid-base reaction. Alkoxide ion, it is acting as an base and it is going to deprotonate, or that is H plus ion from the water molecule. Now see here, this is shown in the mechanical part. See. Now this is our enolate ion which is acting as a base. Now again there takes place regeneration of the carbonyl group. This oxygen electron, they are transferred in between the carbon and oxygen. So again there takes place the regeneration of carbonyl group here. And now as these electrons are coming here, this electron, that is carbon double bond, is going to attack on the carbonyl carbon. So this is the carbonyl carbon which is acting as an electrophilic center, and now this pi bond which is of enolate ion, it is acting as a nucleophile. Now see here, when the nucleophile is going to attack on the electrophile, there takes place bond formation between this carbon, that is alpha carbon, and the carbonyl group of the another aldehyde. So this aldehyde. Therefore, aldol condensation, it is a important reaction in the formation of a carbon-carbon bond. Here takes place new formation of carbon bond. Now, if you look toward this one, this is our this is our starting material, which is having only two carbon atom. This is the second aldehyde. It is also having two carbon atom. But if you look toward this alkoxide, now when this enolate ion is going to attack on the carbonyl carbon, we are getting this alkoxide ion. Now this O minus, it is bearing a negative charge. Okay. So this is an alkoxide ion. And here takes place bond formation between the alpha carbon and this carbonyl carbon. This is the second step of this reaction, formation of alkoxide ion. So first step is the generation of enolate ion, Second step is the attack of enolate ion as a nucleophile to the electrophilic carbonyl group. This is the second step. And third step, that is which will result in the formation of alkoxide ion. And third step here is this the hydrolysis reaction. Hydrolysis means water or addition of water molecule. This is H2O. Now this alkoxide ion base, it is taking proton from this water molecule H plus, and which results in the formation of OH minus as the side product. Again it releases a base. So after taking proton from this water molecule, this O minus is converted into OH. So look toward this. This is H, C double bond O, CHR, CHOH, CH2R. This is our aldol product. Aldol means it is having half part. Ald means aldehyde and OL means alcohol. Therefore, it is a combination of aldehyde and alcohol. And as this carbonyl group, that is the aldehyde carbon and the hydroxyl group of alcohol, they are at 1 and 3 position, that is at beta position. This is known as beta hydroxyaldehyde. So this is the complete mechanism of aldol condensation reaction. The three steps are: first, formation of enolate ion; second, attack of enolate ion on the electrophilic carbon; and third, the hydrolysis of alkoxide ion to give beta hydroxyaldehyde. So this is the complete mechanism of aldol condensation reaction. Now, in this aldol condensation reaction, generally we cannot isolate the aldol. Okay, it easily, as in this reaction, OH minus ion is generated. It is very easily undergoing the dehydration reaction, and it will result in the formation of alpha beta unsaturated carbonyl compound. See here. Now again the same thing, carbonyl group, alpha carbon, they are found to be highly acidic in nature. Therefore, they can be easily abstracted by the base. Again, there takes place formation of such type of enolate ion, regeneration of carbonyl group. These electrons are transferred here and OH minus, it is removed from the molecule. First, H plus from this alpha carbon and OH minus from the beta carbon, they are released in the form of water molecule. And therefore, here we are getting a double bond in the alpha beta position. Therefore, the final product of aldol condensation reaction is the alpha beta unsaturated carbonyl compound. Okay. So this is the complete mechanism, that is aldol formation followed by dehydration, which results in the formation of alpha beta unsaturated carbonyl compound. And this is just the brief summary. An enolate ion is the anion formed when an alpha hydrogen in the molecule of an aldehyde or ketone is removed as hydrogen ion. The first part of this reaction is an aldol reaction, and the second part, a dehydration, is an elimination reaction. So the above part is aldol reaction, and the below part, that is the below the line, is the elimination reaction. See. Now we will see some examples of this aldol condensation reaction. A typical example of aldol condensation involves two molecules of acetaldehyde, that is ethanol. Two molecules of acetaldehyde, they are going to react with each other in the presence of sodium hydroxide, and the product of this reaction is 3-hydroxybutanol, that is beta hydroxyaldehyde. So this product and other beta hydroxyaldehyde are generally called aldol because they contain both an aldehyde and an alcohol functional group. See here, the end product, that is the end part of this product, CHO, it is an aldehyde, and at beta carbon atom, it is having an OH group, that is alcoholic group. So the combination of aldehyde and alcohol is aldol. Okay, so two molecules of acetaldehyde, it results in the formation of 3-hydroxybutanol, which is a beta hydroxyaldehyde. Now we will take another example, that is reaction between two molecules of ketone. This is a very simple example. We have taken acetone, two molecules of acetone. See here, again here, this is CH3, COCH3. Now here carbonyl group, it is having two adjacent carbon atom, and both the alpha carbon, they are having 3 alpha hydrogen atom. So this ketone is also having the alpha carbon atom. Two molecules of acetone, they are going to react with each other to form beta hydroxy ketone. Okay. Now see here, what is the difference between the first product and the second product? Here, this is the aldehyde group CHO, and in the below product, this is COCH3, that is a ketonic group. When the hydrogen of the aldehyde it is removed by any higher group, it converted into a ketone. So two molecules of ketone, they are going to react with each other in the form of sodium hydroxide, and it is converted into beta hydroxy ketone. Now this is 1, 2, 3, 4, and 5. So the name of the compound is 4-hydroxy 4-methyl 2-pentanone. Okay, this is 4-hydroxy 4-methyl 2-pentanone. If we consider this carbon as the one, the carbonyl group is found to be present at second carbon atom. Therefore, it is 2-pentanone, and at the 4 carbon atom, hydroxyl group is also present and methyl group is also present. So it is 4-hydroxy 4-methyl 2-pentanone. This is the example when two ketones, they are reacting with each other to give a aldol condensation reaction. Now, what are the general features of aldol condensation reaction? The aldol condensation reaction is facilitated by minus I group on the carbonyl compound, and it is going to be retarded by plus I group as it is shown in the acetaldehyde and acetone. Now, why the rate of reaction is going to be decreased by plus I inductive effect group? See here, the methyl group is an electron donating group. It is having plus I inductive effect. At the same time, the methyl group in the ketone, they are also having two electron donating group. They are also having plus I inductive effect. Now, what is methyl group is an electron donating group, and we want that the positive charge there must be on the carbonyl group. If a electron donating group is found to be adjacent to the carbonyl group, because of the electron donating nature of the methyl group, the positive character of the carbonyl group is going to decrease, and therefore it is going to result in the retardation of the rate of reaction, and therefore aldol condensation, the rate of the reaction is found to be retarded by the groups which are having plus I inductive effect, and as the reverse or opposite to this one, if it is having minus I inductive effect, the reaction is going to be facilitated by the minus I group. Okay. Now, this condensation is a readily reversible reaction, and the position of equilibrium is not always favorable to the product. As already I have told you that when the starting material is an aldehyde, the equilibrium lies in the favor of the product, and when the starting material, that is the reaction in between a ketone, the equilibrium is lies to the starting material, that is it is going to the left of the reaction. Now see here, we have already, just 1 minute. Now, though this reaction is found to be a very important reaction, but along with its advantages, it is having some limitations also. One first limitation is that aldol product as such, they are not isolated from the reaction mixture. Either they undergo dehydration to give alpha beta unsaturated carbonyl compound, or sometimes they readily forms a cyclic hemiacetol. So this is a limitation of aldol condensation reaction. Now, the extension of aldol condensation reaction is that this reaction, it may takes place between two identical or different aldehyde. We have already studied one example, that is the reaction between two molecules of acetaldehyde. But it is not necessary that always the reaction it is carried out between two identical aldehyde, but two different aldehyde. For example, acetaldehyde, propionaldehyde, acetaldehyde, then butyrialdehyde. The reaction it may be carried out between two different aldehyde. At the same time, the reaction it may be carried out between two identical or different ketone, and the reaction it may be carried out between an aldehyde and a ketone also. But the second type of reaction, when the reaction is carried out between two identical or different ketone, this reaction is not of very much value in organic synthesis, because ketones, they are giving the product in very less yield. Okay. Now, when the reaction is carried out between the two identical aldehyde or ketone, this reaction is simple aldol condensation reaction. But when the reaction is carried out between two different ketones or aldehyde, this reaction is known as cross aldol condensation reaction. See, a cross aldol condensation is a result of two dissimilar carbonyl compounds containing alpha hydrogen undergoing aldol condensation reaction. Now, such type of reaction, they are also having very less value. The reason is that ordinarily this leads to four possible products, as either carbonyl compound can act as nucleophile and self-condensation is possible, which makes a synthetic useless mixture. See, if both the aldehydes or ketone, they are having alpha hydrogen, they can undergo self-condensation reaction. Okay, when the reaction is taking place between the same identical molecule, it is a self-condensation reaction. So both aldehyde, they are undergoing self-condensation reaction. At the same time, both aldehydes, if they are having alpha hydrogen atom, they are able to form enolate anion, and therefore they can undergo reaction with each other, and therefore again they are giving two different products. So if both the carbonyl compounds, they are having alpha hydrogen atom, there is possibility of formation of four products, and therefore such reactions, they are of very less synthetic value. Okay. However, this problem, it can be avoided if one of the compound does not contain an alpha hydrogen, rendering it non-enolizable. So, such cross-aldol condensation reaction, it can be make very important if we carried out the reaction by using aldehyde, one aldehyde which is having alpha hydrogen atom, and the another aldehyde which is not having alpha hydrogen atom. It means that the aldehyde which is having alpha hydrogen atom, it can undergo enolization. It is acting as a nucleophile, and it is going to attack on the second carbonyl compound which is not having alpha hydrogen atom. Okay. So in an aldol condensation between an aldehyde and a ketone, आता बघा, now see here, this is between the two aldehydes and ketone. Now here we will take an example of aldehyde and ketone. When the cross condensation reaction, it is carried between aldehyde and ketone. Now we know that when we compare the reactivity of aldehyde and ketone, aldehydes, they are found to be highly reactive in nature because it is having only one methyl group. If in acetaldehyde, if it is formaldehyde, then this is the most reactive carbonyl compound. But as the in the ketone, the hydrogen is replaced by another group, the reactivity of carbonyl group is going to be decreased. So when in an aldol condensation reaction between an aldehyde and a ketone, the ketone acts as the nucleophile. Okay, ketone acts as the nucleophile, and its carbonyl carbon does not possess high electrophilic character due to the plus I effect and steric hindrance. So when aldehyde ketone is having alpha hydrogen, we have to generate a enolate ion from the ketonic compound, and then it is going to attack on the carbonyl group of the aldehyde. Usually the cross product is the major one. Any traces of the self-aldol product from the aldehyde may be disallowed by the first preparing a mixture of suitable base and the ketone, and then adding the aldehyde slowly to the said reaction mixture. In this way, cross aldol condensation reaction, they can also be made very important in organic synthesis. Now see, this is one of the very important reaction of cross aldol condensation reaction. Here we have taken a reaction between benzaldehyde and acetone. Now here acetone is having, see here, CH3CO CH3 alpha hydrogen, and this benzaldehyde is not having alpha hydrogen. Okay, so this is a cross condensation reaction of important synthetic value. Now we have to generate a enolate ion from this methyl group alpha hydrogen containing ketone, and then this is going to attack on the carbonyl carbon of the benzaldehyde to give the aldol product, followed by dehydration. It will result in the formation of alpha beta unsaturated ketone. Okay, so this is a very good example of benzaldehyde and acetone. And this is another second example. This is an example between, this is a aldehyde and a ketone. Here also we have to carry out the same thing. We have to generate a carbanion followed by enolate ion formation from this alpha carbon of carbonyl group, which is going to attack on the carbonyl carbon of the aldehyde to give aldol. See, this is the aldol product. That takes place formation between the CH2 of the acetone and the carbonyl carbon. This one, which is shown here, CH2, C double bond O, carbon carbon bond formation. So these are some representative examples of cross aldol condensation reaction. Okay, I think this is the aldol condensation reaction. Thank you.